Machine learning model, they fall under three main categories: supervised, unsupervised, and reinforcement learning. In supervised, you have labels. Your data has labels. In unsupervised, your data do not have labels. In reinforcement learning, you are working through the principle of action and reward. Now, in supervised learning, there are two types of problem we deal with: classification and regression. In classification, we are trying to predict categorical values. For example, is a customer, is he going to default on a loan? It could be yes or no. This could be 0 or 1. Blood pressure, is it high, is it low, or is it medium? In this case, these are categories. Iris flower dataset, maybe you're trying to predict what type of flower that is. Is this setosa, is this versicolor, or is this virginica? Is it going to rain today? Yes or no? What type of disease a patient might have? So these, they fall under classification. Let's take a look at a classification problem. Suppose this is the data that's given to you right here, and you have to predict what type of weather condition is it going to be based on this data right here, based on the date, precipitation, temperature maximum, temperature minimum, and wind. So in this case, you have to predict whether it's going to be drizzle, whether it's going to be rainy day, whether it's going to be sunny or snowy, these types of categorical values. So they fall under classification. This is another instance of classification. Suppose you're trying to build a machine learning model that's going to make a prediction that what type of flower it is going to be based on sepal length, sepal width, petal length, and petal width. And there are only three types. You have setosa, you have versicolor, and you have virginica. So depending on these three, depending on the dimension of your sepal length, sepal width, petal length, and petal width, it is going to make a prediction on what category or what class it falls under. And then you have regression problems. In this case, you're trying to predict numeric value. These numerical values, they tend to be continuous in nature. In other words, they can take wide range of numbers. So they can possibly be infinite. For example, predicting house price, predicting number of bike rental based on the weather condition, predicting the probability of rain today. So suppose you're given this data right here. This one actually talks about how many bikes were rented based on certain day, month, year, season, holiday, weekday, all these things right here. And this column right here, it talks about how many bikes were rented. So you have to use a regression machine learning model that will predict the number of bike that was rented based on all these values, all these column values. So in this case, the number of rentals, these are your continuous value. They can take a wide range of numbers. And then you have unsupervised learning. This has again three further subcategories: clustering, association rule, and dimensionality reduction. In this particular instance, we are trying to determine hidden patterns, structures, or relationships that exist in your unlabeled data. So, for example, let's say this is your data right here. It gets fed to your unsupervised machine learning model, and your machine learning model is going to create clusters. It's going to determine which group of points belong together. So, let's say it finds two clusters in this case: cluster one, cluster two. So, this is what your unsupervised machine learning model does. So for unsupervised learning, an example of clustering would be in customer segmentation. So for example, a retail company, it may want to group its customer based on their buying habits, their browsing patterns, and their demographics. So this way, they can group them together. By grouping them together, let's say these are your customers, and they groups them, and let's say this is one group and this is another group. So now they can create targeted marketing campaign for this group, and they can have a different strategy for this group of people. Another example of clustering would be in the field of bioinformatics. So clustering, we can use it to group genes that has similar expression profiles. This way we can identify the underlying biological relationships between these genes. Now, let's look at the case of association rules. In this case, it involves finding relationships or co occurrences between items in a data set. So, let's understand this through a market basket analysis. So, suppose a retailer he discovers that customers who buy bread, they also frequently buy milk, jam, and butter. Now, this information the retailer can use to optimize your product placement and promotion. Maybe he can put your bread, butter, milk, jam all together at one spot. Another example of association would be in recommendation engines. So streaming services like Netflix or other place or other sites, they suggest movies based on a user's behavior, based on his historical behavior, and what other users with similar taste have consumed in the past. So, for example, if you have seen movies like Predator, Aliens, Interstellar, then recommendation engine, they may recommend you sci-fi genre movie like Gravity, because people who have liked Predator, Aliens, and Interstellar, they also have liked these types of movies. Now, unsupervised learning also can be used for undimensionality reduction. In other words, it can help reduce the number of dimensions or features in your data. Suppose you have a data that has 100 columns or 100 features. So using dimensionality reduction, you can reduce it to say maybe just three features, just three columns. And this process basically involves like combining few of these columns to create a one single column, or maybe removing irrelevant column that has no effect on your data or provides no useful information on your data. And then you have reinforcement learning. In this case, you train an agent to make a sequence of decisions in an environment to maximize its reward. The sequence of decisions he makes, these are also called actions. So, for example, robotics, self driving car, video games. So, let's understand this through an example. So, suppose you have a self driving car right here. This will be your agent, and this agent is performing action on the environment. Here, my environment would be road right here. So, this car is driving through the road. So in this case, my environment is going to communicate with the agent, is going to communicate by giving it a reward and also giving it a state, what state it is in. Reward can be in the form of plus number, like +1 if he's driving right, or -1 if he makes a mistake. State would be where exactly the position of the car is. Maybe the car is over here, maybe it's over here, maybe it's over here. So these things they refer to your state. Action refers to what the car is doing. Should it go forward? Should it go left? Should it go backward? Should it stop? Should it move backward? So these are your actions right here. So to recap, in supervised learning, you're trying to predict. Either you're trying to predict a class or maybe you're trying to predict a numerical value. In unsupervised learning, you are trying to find patterns, clusters. In reinforcement learning, you are trying to maximize your reward based on the action you perform.